Chemical reactions involve changes in compounds, specifically creating them or degrading them. This occurs as a result of chemical bonding, which occurs when electrons orbiting the nucleus of one atom are shared with another atom, lost to another atom, or taken from another atom. When the electrons of one atom are associating with another atom, the two atoms are stuck together. They are bonded. Not all the electrons in an atom can take part in chemical bonding, though. Only the ones with the most energy that are the furthest from the nucleus can interact with other atoms. These particular electrons are called valence electrons. The electrons orbiting the nucleus of an atom are usually categorized into different energy levels. The ones closest to the nucleus have the least energy, and the ones farthest away have the most. There are only 2 electrons at the lowest energy level, but from then on, there can be up to 8 at each level. If an energy level is complete, meaning it has 8 electrons, it is non-reactive and won't take part in forming chemical bonds. Since they fill in from the lowest energy level to the highest, those at the highest level, the valence electrons, are the only ones that may not have a complete set and that may form chemical bonds. If an atom only has 6 on its outer energy level, then it wants to find 2 more to get up to 8. It can form a chemical bond with another atom and either share or take 2 valence electrons from it to do this. If an atom has 1 valence electron, then it is easier for it to just give away the 1 than it is to take or share 7. So, it will probably do that. If an atom has 7 valence electrons, it is probably easier to take 1 than it is to share or give away 7. So, it will probably do that. However, if an atom has 4 valence electrons, it's probably easier to share 4 electrons with other atoms than it is to give or take. Basically, atoms tend to react in ways that get them to 8 in the most direct way possible. The periodic table helps us to determine how many valence electrons each atom has. Those in group 1, column 1, have 1 each. Group 2 each have 2. Then the next chunk, those lower ones called the transition metals, have variable valences. Some have 2, some have 3, and some vary based on isotope. Once you get to the next section, though, starting with group 13, they are organized again. Group 13 has 3, group 14 has 4, 15 has 5, 16 has 6, and group 17 has 7. And the last group in the far right has 8 electrons at its highest energy level, meaning that they all have a full outer level and don't need to form chemical bonds. This last group, as a result, has 0 valence electrons. These elements are called the noble gases. We're all trying to get to 8. Those ones to the right, which are just a little short of 8, tend to react with those on the left, which basically just have a few extra past the energy level below. For example, sodium in group 1 likes to react with chlorine in group 17. They do this because sodium has 1 valence electron and chlorine has 7. So if sodium gives its 1 to chlorine, it can go back down to a level where it already has 8, and chlorine can go up to 8. There are different types of chemical bonds based on whether the valence electrons involved are transferred from one atom to another or shared. Depending on the type of bond holding together, the compounds will have different properties.